Good morning, dear students. Last time, when we had the previous lesson, we were trying to look at differentiation and we tried to look at several ways of how can we differentiate. And now you're very conversant with the YDX, and it was very interesting. And I saw some people were responding, sending some messages on email, WhatsApp, saying that, the majority of them passed. And I was very, very happy and I was very, very impressed. Now, still, we are continuing with much on differentiation. And the first one we are going to start with, differentiating from the first principle. We are going to look at differentiation from first principle. So I want to look at how do you differentiate from first principle. Because when you come and say differentiate from first principle, when I say differentiate from first principle, you must differentiate from the first what? Principle. But if they say differentiate with respect to x, you are free to use which one is good for you, which one is for you. But now we are saying we are going to look at differentiating from the first what? Principles. Procedures. Well, maybe before we go to procedures, concerned by saying if y equals f of x, if y equals f of what? Of x. So I'll start by saying procedures, or what we call methods. The first is if they have given a function as f of x and you have said that y equals f x, call it the first equation. You can say, you say y, let y equals fx, call it first equation. Call it the first what? Equation. That's the first step. They may even say differentiate fx from first principle. You start by saying let y equals f what? X. Call it the first step or first equation. Then from there, you move to another step. You say taking small changes as delta y and delta x on y and x respectively. On y and x respectively. So you take small changes, the small increments, small changes in them in y. So when you say y, you are going to say y plus delta y equals f into x plus delta x. And you say this is the second equation. So taking a small changes in the variables we have taken in y and x. That's why you can see y plus small change in y. That's why we're calling it a delta y. Then you say equation 2. Then another step, this was the step 1, then you go to another step, you say this was step 1, this is step 2, go to step C. Then you say subtracting equation 2, subtracting equation 1 from 2. Equation 1 from 2. That means we are talking about equation 2 minus 1. So what is equation 2 saying? We are going to say equation 2 is having y plus delta y minus equation which is already y, which is already f into x plus delta x. Equation 2 minus f of x. So what happens with y and y remain with delta y equals f into x plus delta x minus f of x. So you can see when you have reached that another step. The step 3 is you get the equation 2 which you have taken the small changes, you deduct it with the original one. So you come out with that. Then you go to equation 4. Then you say, dividing by delta x on both sides. Dividing by delta x on both sides. So what are going to remain with? Plus what are going to remain with? We are going to have delta y out of delta x. Are you getting that? Equals f into x plus delta x minus f of x all over delta x. You can see where you have reached there. So after dividing by that, we are going to move to another step. So the whole of this one, you divide it by delta x by small change in x. Then we are going to step 5. So after dividing by delta x, then we say as delta x, as in the place as delta x tends to 0, then delta y over delta x is approximately equal to y dx. So you see, where you see delta y over delta x is the same as the y dx. We say therefore the y dx equals f into x plus delta x minus f of x all over delta x. This is the first principle which we are going to be using as delta x tends to 0. So we are going to have examples. Example 1. Differentiate x squared from first principle. Differentiate x squared from first principle. Differentiate x squared from first principle. So what we're going to do is this. We are going to follow the same procedure as which we have already said practically. The first one we're going to say let y equals x squared. So this is the first equation. Then we say taking delta y and delta x as small changes in y and x respectively. Read the statement very well. You are informing an examiner that what you are doing, you are aware of it very, very well. Even the examiner becomes more and more impressed that this child, what he or she is doing, knows it the better. So taking, you're going to have y plus delta y equals, where is x in x plus delta x, the order of it what? Squared. Very, very good. We say this is the second equation. This is the second what? Equation. What do we say? We say equation 2 minus 1. Equation 2 minus 1. Can we go ahead? We're going to have y plus delta y minus y. Because this one's there and this one's the same. Equals x plus delta x, the whole of it squared, minus what? X squared. Very good. You can observe here, y minus y, the value is only delta y. Equals, this one you can see the difference between square, or you can expand this one 2 times. When you expand this one is happening 2 times. What does it become? It's going to be x plus delta x is the first time. Again 2x plus delta x, then minus x squared. We are going to open using layman's. How do we open? The first variable into the second. We are going to have x into x plus delta x. Then here is plus delta x into x plus delta x, then minus x squared. Then can we expand? Remember, let's expand together. Let's expand together. We need to expand together. We need to expand. We need to expand together. We need to expand. So we're going to start with x times x. What do we get? Remember what we get? X squared. X times that plus x delta x. Very good. Delta x times that, we also get plus x delta x. Delta x times delta x, we also get delta x. The whole of it is squared minus x squared. So what do we get? X squared and x squared, this one is going to disappear with that. But I don't advise you observe, even if you don't cross, observe and understand. What is going on now? This is the same as this plus this will only get 2x delta x plus delta x squared. I get that? Which is already delta y. So, after getting that principle, what do we do? Remember, we need to go slowly, then we can easily understand each and every concept which is being put aside for us. What do we do? So, I said from there, we say dividing by delta what? X. And we say dividing by delta x on both sides. What do we have? We are having delta y. Before we move to that, there is one concept which we have not seen. A small change times a small change, you get the, you say, match delta x squared equals 0. If you get a small change times a small change, the answer is always 0. A small change, when you use a small x times small y, you get a 0. Small x times a small change times a small change times another small change, you get 0. So a small change does not matter with it, you get a 0. So what we remain with? We remain with delta y equals 2x delta x. Are we there? So we say dividing by delta x, dividing by delta x. On both sides, what do we have? Delta y over delta x equals 2x delta x over delta x. Delta x does what? This and this disappears. And next time salon becomes also just observing. What do we remain with? Delta y over delta x equals 2x. Then we say as delta x tends to 0, comma, then delta y, delta x is approximately equal to dy dx. So what is happening here now? We remain with dy dx, which is 2x. Therefore, d dx of x squared, we are going to come out with 2x. This is what you come out with. Even if you have already done it somewhere, let's look at the side work here. Side work. We said when you differentiate x squared, what were you getting? Remember the step. We said you bring that power down. Then you deduct 1. What happens is 2x or 2 minus 1. You get 2x power 1, which is already 2x. Again that, which is the same as this. But if they say That's why I say that with this differentiating like ddx of x power n, where we say you just say n x power n minus 1. This is what it was in the past. But now we have used the first principle and we have tried to drive, we have come out with this. So I call upon that when they have said use from first principle, always use first principle. We are here clear with that. We need now to go to another. We need to go to another example. We need to go to another example. We need to go to another example. To go to as example, where to can lay out the concepts that we can easily understand. So we just go to example 2. Example 2. I've said differentiate. X plus 4 from first principles. So we want to differentiate that one from the first principles. So bear in your mind, we are using the process already given from the start, so that we can easily come out with it. I know if they say plus 4, when is it somebody? When differentiate x is 3, differentiate 4 you get a 0, the answer is going to be 3. But we want to do it from first principles. How do we do? So start by saying that y equals 3x plus 4. This one becomes the first equation. This one becomes the first what? Equation. Then we say taking very good delta y and delta x as small changes on y and x respectively. So I'm taking those small changes. What am I going to have? Y plus small change in y equals 3. Where is x put 3 into x plus small change in x, then plus a 4. Are you getting that concept? Then this one is the second what? Equation. Then we say another procedure comes in, we say equation is 2 minus 1. Are we there? So when you present this work, the examiner becomes more interested in you. Say this one, wow, very interesting. Equation 2 minus 1. Now what we be taking? Y minus 1 equals, we are going to make with what? Delta y, because we already know about the first concept. There is no need of us to repeat this one. Equals 3 into x plus delta x, then plus 4, then minus, what is the first equation saying? The first equation is having 3x plus 4. Put them in bracket that. Then we are free to open the bracket. Have you seen another of the thing is enjoyable? Yes, let's put together. We get what in 3x push plus 3 delta x, then plus 4 minus 3x. A negative times a positive, you get a negative. Very good. Very good. I'm very happy with you now. So 4 and 4 goes 3x, and 3x also does what? Because you can say 3x plus a 4 and a 4. Have you seen that one? So what have I made with? I mean with delta y equals 3 delta x. Then I said when you reach there, what do? Who can record? Yes. You say dividing by delta x. Yes. This is a very interesting class. Dividing by delta x. Dividing by delta x, we say delta y over delta x equals 3 delta x out of delta x. Yeah. Can I read here? No, we need to go up. We need to go up. You first see this concept before we move to this. You first like this and we proceed. Hey, you understand that y equals x plus 4? And an examiner would be happy. Would be saying, the child what is doing, he or she knows it very what? Very well. So be very, very, very paramount. Then from there, remind the examiner that taking delta y and delta x as no changes in y and x respectively. Then from there, we shall go to y plus delta y equals c into x plus delta x, then plus c, therefore. Our small changes will only put where it is y and where it is x. Then from this equation 2 minus c, 1. Then we came out with delta y equals c delta x. Then we remember there's a procedure dividing by delta x. We divide by delta x. So we have come with delta y, delta x equals 3. So where we are now moving. Let me hope you have finished writing that one. Because I've tried to check there, you people have finished. Well, when you can do answers, then I've already got the answer. We want to move faster than the teacher. No, you don't want me to continue teaching because now you are busy doing things more than me. You want people to say, so from there. These are good sub students. Well, I've got delta y. Let me finish it back. Delta y, delta x equals 3. Then we say as delta x tends to what? To 0. Delta y, delta x is approximately equal to dy dx. dy dx. Very, very good. So I've got dy dx equals 3. Therefore, what is called therefore ddx of 3x plus 4. We are coming out with 3. Very good. Since you have said that, so we are developing that, then we are also adding another one. Not so that by the time when we reach when I live an assignment, people have already done great work. Do you have any question there? I think if you have a question, follow me down the third example, which we are doing. By the time when we reach there, nobody will be asking this. Here, we need to write it here and we start afresh. Here, that's what everybody do. And when somebody do it well, so just give that person the asset sana. And when I say asset sana, when somebody does very well, says, I'll just say asset sana, then you just give 2 claps around. Chap, cha 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 cha. That person will have already find that. So let's proceed to another example. Example 3. You see now these things are very good. Differentiate here 2x squared plus 5x from first principle. Hey, with number is that from small. Hey, the assignment you are projecting when you are doing it faster than me. Now we have to move. You can see we're following the same steps, after following the same steps, and the things will move on very, very well. So we're going to say what? That you were very good, that y equals 2x squared plus 5x. Call it first D, because don't forget that. Then somebody, because when you forget, I will be annoyed, hey, will be very annoyed. So you need to be remembering that that is the first thing. Then we move to the step of saying taking delta y and delta x as small changes, very good, as small changes in y and x respectively. So what I'm going to do, where there is y, put a small change in y. Where there is x, put a small change in x. What are we going to have? Y plus a small change in y equals 2 into x plus a small change in x. The order of it is squared. Very good. Don't only say x squared, x plus small change, all of them are squared because they have already both the other small change. Yeah. plus 5 into x plus small change in x. Very good. You can first expand, then you subtract. Oh, you can just start from there. So me what I would say, since there it is going to be more complex, first expand it. Then you solve over. We have got y plus small change in 1 equals 2 into. Can we expand that one? The bracket is appearing 2 times. Let's expand using lemons. You also x plus delta x first, again x plus delta x, another one. Then you say x into the other one, plus delta x into the other one. So after expanding, check in the first example, which is with, we are going to come out with x squared plus 2x delta x plus delta x squared plus push in 5x plus 5 delta x. Clear? Push in now. But you see, when you say delta x squared, you put a what? A 0. But the small change squared is equal to 0. What do you remain with? You remain with y plus delta y equals 2 into x squared plus 2x delta x. The other is already 0, you already see plus 5x plus 5 delta x. Now, from there, push in. We are going to have y plus delta y equals 2x squared plus, this times this, what you get? 4x delta x. Have good students. Plus 5x plus 5 delta x. Can we correct terms? Yes, no problem. We say y plus delta y equals 2x squared plus 5x plus. This one is related to that. Is it related? Yeah, not. We say plus 4x delta x plus 5 delta x. Say this is the second. Then find out 1. Equation 2 minus 1. What is equation 2 having? You subtract your root remain with delta y equals equation 2, the way it is 2x squared plus 5x plus 4x delta x plus 5 delta x minus. What is the first equation saying? The first equation is having 2x squared plus 5x. Then from there you are free to push in. Let's push in. Root remaining with delta y equals 2x squared plus 5x. You need to go through the plus 4x delta x plus 5 delta x minus 2x squared. Now, if you get it as a positive, you get a minus 5x. See mathematically, 2x squared plus 5x, 5x. Have you seen that this thing is probably going paramount? So, what do we remain with? Chems must be read daily, mathematics must be read daily. If you are doing BCG, stroke sub mass. If you are doing BCM, biology must. If you want to become a doctor of tomorrow, you want to do Bachelor of Science in Agriculture, embark in these subjects. They are very crucial. You need to be very, very serious on this. And mathematics becomes simple so long as you practice. But if you relax, even the little which you have will just evaporate from your head. So, if I add another example which you are going on, let me first give you a break as well, busy jangling on that. Otherwise, we are going to proceed with another one. Good morning.
Wait, is this recording?
Good morning, dear students. Today we have come to also continue with where we had stopped the assignment. We are trying to look at differentiation from the first principle. Now we are want now to move on how to do more examples related to that. So as earlier told you, how we can do these examples using the first what? So we are going to say more examples. More examples. More examples. examples on the first principle. First principles. The first one is differentiate. Differentiate. Not yet clear. Saying differentiate. Differentiate, you can be writing differentiate root x from first principle. Saying differentiate, you will write it differentiate root x from first principles. X from first principles. So what do we do? With this, the same story. We are not changing any format. We are going to say let y equals root x. Call it first equation. And then the square root is like our half. So what you do also go and say taking delta y. Say taking delta y and delta x. Small changes in y and x respectively. So what are we going to have? We're going to have y plus delta y equals root, yes, x plus delta x. This is the second equation. You can see. Then from there, say equation 2. What are we going to have? Y and y equals remain with delta y equals root of x plus delta x minus root x. Get that? Now how do we do numbers with this? Now when it comes like this, you rationalize. You rationalize the y dx, which is equal to negative 2x all over x squared into x, that is already 0 because they said as tends to 0 squared. What do you remain with? Negative 2x out of x squared. Then inside you also remain with x squared. You are going to get negative 2x out of x power 4. X squared times x squared will get x power 4. Then this x reduces with x. What do you remain with? Negative 2 out of x cubed, which is x. Therefore, d dx of 1 out of x squared, you are going to get negative 2 out of x cubed. That's how we handle this. And if you happen to do it in the other way, you will get the same. How many want us to try the same? I can try it because some of you need to it. But if they say from first principle, answer. So manually, I've said manually, if you're going to say manually, let this is like side work. Let y equals x 1 over x squared. So I said you never differentiate when number is down. Take it up. And when you take it up, it becomes negative. So what is happening? Y equals x negative 2. You see? Then I think of this is becoming negative. Then you go in the then you connect 1. What is going to happen? We are looking at now d dx of y, which is equal to d dx of x over negative 2. So what do you get? Y dx, which is equal to negative 2. What happens? X, you say negative 2 minus 1. What does it become? Negative 2 x power negative 3, which becomes negative 2 out of, this one comes down now. When it comes down, the one comes positive. So, have you seen how this is related to this? That's how we normally avoid. So, whenever I tell you differentiate in that way, then go ahead and differentiate in the way how they have already told you that. And if a question comes and say differentiate from the first principle, kindly differentiate from the first principle. But if they say just differentiate, and you say that first principle is good for you, then I have no problem with that. But if the question comes and say differentiate from that, it will not change in that way. So, as people have been said, yes, people have asked, because that was my thing, then some people asked this question which I want to do. Who asked? Was there? Somebody asked this, which I want now to do. And they will just give you a hint, then you will just finalize with it. The question goes, differentiate one out of x from first principles. Here, somebody asked that. That's what we want to do, and we see how we are going to come out with it. So the same procedures. We shall say let y equals 1 out of x. Say this is the first equation. That's all. Then we shall say taking delta y and delta x as small changes. Small changes in y and x respectively. That one, don't forget it. Because some don't know that what you're doing your way. What do we have? Y plus small change in y equals 1 out of root of x plus small change in x. This is the second. Then from this equation 2 minus 1. What do we have it? This remain with delta y equals 1 out of root of x plus delta x minus 1 over root of x. Then from there, we can find the LCM. Delta y equals, what is the LCM? Is root x into root x plus delta x. This one very that times that you get root x minus this one very that you get root x plus delta x. So I think you have seen how the step is now moving on. Then from there, what do we do? What do we do? So what we can do is now 1. We can, since this one's identical, we can multiply them together. We can multiply them together. Or still, you can even go ahead and find and you rationalize. Still have no problem with that. You say delta y equals root x minus root of x plus delta x. You rationalize the denominator into root x plus root of x plus delta x all over. From the roots, you can just say it one root. x times get x into x plus delta x times what you have done up must do it down to x plus root of x plus delta x. So that's what some of you were asking this. Then from there you are free to proceed and finish it. So because you are asking it, then I decided to come and give you the way how you are supposed to do it. So I'm expecting you in your groups, try to practice and finish it. Otherwise, I wish you well. Peace out.